Right, here's a demo of Forth running on a propeller chip over here. Over to your left here you can just see it. I'll just move around. We can see the propeller chip over here. We have Forth running on this, and it's connected to an I/O port expander on the I2C bus. On there are 6 LEDs that we have over here, 1, 2, 3, 4, 5, 6, and 2 other signals. What I'm going to do is just run this little bit of code here which writes to the I2C chip using its address at 40 and just writing to the registers that we address. And then we can create an LEDs word there that takes a byte, and we'll write to all at one time, and then initialization word, and also over here one that can turn individual LEDs on and off by maintaining a variable for the LEDs, so that we can individually set them and reset them. So let's try that out. Let's come back up in here. This is running now. So we're going to try that out. We're going to turn on an LED. So I'm going to say on for LED, whichever that is. Does it come on? I don't see anything at the moment because I've cleared it all out. So I'll grab all this, copy that, paste that in, and then we'll just fix this one up. This is a different terminal here. Try this again. Here we go. Now what we want to do is turn on for LED according to this syntax that we have up here, which is the state on or off, 0 or non-zero, and the number of the LED, and that will generate a bit mask and all that with the variable over here, and then write that back out to LEDs routine over here, which will of course write it to the correct register for the LED output. So let's see that working, and we'll turn that on. Well, I haven't initialized them, have I? LEDs dot emit. There we go, and then alright, that's because I haven't initialized this variable either, or something rather. It's all low, they're all on. That's what it is. So I'm going to put a I'm going to turn them all off directly like this, and on for LED. Right, there's only one LED on now. That's what should have happened. And of course I can write 0 to turn them all on to the LEDs word over here, which takes the 8 bits of data and just writes it directly to that, like so. Or I can do that FF that I just did before, which will write to the variable over here, and also write to the LED register, so LEDs. There we go. Now we can say on 5 LED, off 5 LED, on 6 LED, and off 6 LED. And from there I am going to run a little demonstration where I initialize the LEDs and go through, and 8 times through I will use the index 0 to 7 that's generated and tell it to turn on 0 LED 50 milliseconds, off 0 LED, loop back, on 1 LED 50 milliseconds, etc. Let's have a look at that working. Here we go, demo. And we only have 6 LEDs hooked up, but if we had all 8, then we'd see them running like that. That's very easy to change as well, because we can stop that. I can even say in a quick little loop like this, let 0 do on ILED 200 milliseconds, off ILED, and loop. Just try this. That was nice and easy too, wasn't it? Of course I can put that in a continual loop once again, do the same thing, begin, 8, 0, do. This time I'm going to do it a little bit differently. I'm going to go on ILED 50 milliseconds. We'll get this right, case sensitive. But I'm not going to turn off the LED this time. I'll let that go through, and once that's done I will tell it to do the same again, and this time turn off the LEDs. off I LED, 50 milliseconds loop and key until. Totally different effect now. We can see them all staying on and then all turning off again. As soon as I hit a key, that will generate a non-zero, whatever the key is, code, and that will stop the loop. Done. Easy as that.